Hello everyone. Uh, Good evening. I hope you are able to hear me. This is Moolshanker, the co-organizer of Hyperledger Abu Dhabi and Hyperledger Dubai. And we have today with us Mr. KC Tame. He is a speaker today for today's session for application development in Hyperledger Fabric. He is from Hong Kong. He is a founder of a company in there, and he is the founder of Ledger Tech, and he has written so many articles regarding the blockchain and other technology. And currently, he is working as a founder of a company. And I think Mr. Casey will give us the detailed introduction. Now it's we are ready to go, and Mr. Casey, now stage is yours, so
Thank
you
you, Mo.
can go.
So I hope everyone.
One more thing. Sorry to interview. One more thing. Today we have a session of 2 hours session today. 1.5 hour will be the presentation, and there will be the 30-minute question and answer section. So you can write your questions, and in the end, last 30 minutes, Mr. Casey will be giving you the answer of the questions. So yes, sorry, you can
Okay.
continue now. Okay.
All right. Thanks, Mo. Hi. Good afternoon, everyone. This is Casey. I'm based in Hong Kong. I'm very happy to be invited in this WebEx, this webinar. Just a little bit quick introduction on myself. I start my blockchain journey for more than 2 years. I have been working with companies like Cisco, like Ericsson. So I'm more on the technical background, more on the consulting business, providing consulting service to my clients. So since then, I start my company, and mainly I'm offering training classes, workshops for my clients, and sometimes in some universities. Recently, I'm also participating into some blockchain projects. Here, I have to say that in Hong Kong, it's quite popular. More and more companies are looking for blockchain in general, and in particular on Hyperledger-Fabric. And that's why I'm also keep trying, testing, and document quite a lot of what I have learned and what I have practiced. And I'm always glad to share with others. I hope the community become bigger and bigger. So today, my session, there will be a huge section. I have to say that. But mainly, I would try to make it into 4 parts. The first part is more on a quick review on Hyperledger-Fabric. This is not a Hyperledger-Fabric 101 classes, so I suppose you might have already get some ideas on Hyperledger-Fabric in general, but I just try to make a quick review on the platform itself, some concepts, just making like a consensus or a synchronization on the audience. And then we'll go into the application. So the first application we try to cover is the FabCar. FabCar is something provided in Hyperledger-Fabric, Fabric samples already. But this is a good example because it let us know what actually an application should look like when it is built on top of Hyperledger-Fabric. And later, I'd like to share with you another case that is the invoice finance. I published this, I guess, a month ago, and I received quite good comments and people saying that, okay, finally they know how Hyperledger-Fabric can be used in real business. So I try to share this with you. I come up with this idea because some customer is asking me, so I just built some proof of concept. But anyway, I will touch on the invoice financing, and based on the idea, the business case, I will share with you the chain code and also the client application. And let's take a look on what actually the application is looks like. And finally, I'd like to share with you some of my experience, in particular on the building a blockchain application. In particular, how come, the consortium environment is good when we talk about blockchain. So this is the agenda I covered today. So first, we will take a look on the quick review Again, nothing new. Just make a synchronization to make sure everyone knows, at the same page. So it's an open source project. We all know that is from Linux Foundation, Hyperledger. Nowadays, they call it a greenhouse. In fact, they have many projects nowadays under the Hyperledger umbrella. So it is an enterprise blockchain platform. Compare when we talk about Bitcoin, Ethereum, they are more on the permissionless public blockchain. So Hyperledger-Fabric is more on the enterprise side. It comes with both two things. The first thing is the infrastructure, and sometimes I call it network. So sometimes, if you find it later, I use the term infrastructure or network. We are talking the same thing. That is the foundation, the network that you build, and then it is the programmability provided. As the smart contract capability. So when I say Hyperledger-Fabric, we usually come up with these two parts. One is the infrastructure. One is the application. More on the smart contract as well as the client application. So I have to say that this is by far the most popular enterprise blockchain platforms. In the market, there are three. People keep saying that, okay, Hyperledger-Fabric. The other tools are Quorum and also the R3 Coder. And in fact, at this stage, I won't in particular saying that which one is good, which one is bad, but it's more from a use case perspective, from the media coverage. I have to agree that Hyperledger-Fabric is in the leading position. So 2 years ago, we have the release 1.0, and that means in production. And currently, we have we have 1.4. That is the first LTS release. As of today, I know that there's a 2.0 alpha at this stage, but for demonstration, for testing, for proof of concept, I'm more using the 1.4 at this stage. So this is a greenhouse. I keep seeing this changing. When I first see it, there are 10 projects, 5 ledger and 5 toolset. And now you can see there are 15. And today we are more focusing on the Hyperledger-Fabric part. I have to say that other projects are very interesting. In particular, I'm very fond of the Hyperledger Indie. And this is another area I'm exploring right now. So that's why you probably will see some articles from my side on the Indie as well. So I mentioned that there are 3 big enterprise blockchain platform as of today. And there is a case, I guess it's 2 years ago. It's from Singapore, the Monetary Authority of Singapore. That is, in fact, is the central bank. Singapore. 2 years ago, they invited. They have built a case that is how central bank doing the real-time gross settlement. And in fact, they have invited 3 enterprise blockchain platforms together to build. They put up with a case and then let them to build based on their platform. So this is a good report. In fact, you can see there's a link at the bottom. And in this report, you probably can find out how they build, from architecture perspective, how they build their chain code. In fact, I remember, in fact, everything is on GitHub and you can in fact access them. So you can see, on the same business case, you can build it with Hyperledger-Fabric. You can build it with Quorum from JP Morgan, and you can also build it with Coder from R3. And inside the report, you can find some pros and cons on each platform. So this is a very good reference. You can take a look on how these 3 platforms are doing in particular. When an application is built on it. So when we pull back on Hyperledger-Fabric, or in fact in general on blockchain platforms, I usually divided them into layers. It helps us much easier to understand what actually, when we talk about a component or a concept, we can easily say that, oh, okay, it's on the infrastructure part, or it is on the application part. So when we talk about, when we say the infrastructure, in fact, we are talking about the nodes. The actual physical components building the network. In Hyperledger-Fabric, you probably know that we have peer, we have orderer, we have CA. So these are some nodes. how the nodes are communicating to each other. So it is more on the inter-node communication. The data structure, in fact, is sometimes we call it the blockchain or the ledger. In Hyperledger-Fabric, we use ledger more because, I mean, inside the ledger, we have both the blockchain and the well-state database. We'll show it later. And there's a consensus algorithm or mechanism to make sure the data are all in the same. I mean, although we have many nodes, I mean, inside the network. And finally, there is an execution environment. That is where the chain code is executing, where the chain code is functioning. So is my voice still okay? I've noticed that there's some disconnection, something look like. Okay, so thanks. So this is okay, thanks. And so this is the next part is on the application. So once you have the network, you have the infrastructure, you can build your application. In fact, the application, we always saying that is something interacting with the data inside the blockchain. So it is, I mean, either is the data, is the execution logic, and also in some public platform or even in Hyperledger-Fabric, you have some ideas like wallet, which is the credential you keep when you initiate or are making a transaction in the network. And finally, there are a lot of tools like the interfaces, like the libraries that, I mean, construct the whole blockchain network. So we break it down. The first one I'm touching on is the infrastructure. So the infrastructure inside the Fabric network, there are two examples. I always use these examples when I'm doing some demonstration or proof of concept, or I mean, developing my chain code. So the first one is basic network. Nothing new, nothing special. It's the most, the simplest networks so far I see in the world. So there's an orderer organization. There's one organization called Odd1. Inside Odd1, there's a peer. Inside Odd1, is my voice still okay? Okay. Yeah. Because I noticed a message coming up saying they can't hear. Okay. Just let me know in case you cannot hear. Just type on the chat. Sorry about that. Keep interrupting that. So inside the basic network, there's one peer. We call it peer 0. So when you see it, it's peer0.odd1.example.com. And it come up with two components. One is the well-state database. In fact, it's deployed in a CoachDB. So nothing special. It's good for us to inspect the state data. In particular, we can use a browser to take a look on what's inside. And there's a certificate authority, the CA here as well inside the Odd1. So this is how the basic network looks like. And if you got some time to play some hands-on, you can go to the Fabric network. Just go to see basic network and do a start, and you can see the Docker containers in this in the basic network. So you can see a peer, a CoachDB, which is the well-state database for peer. There's a CA there. There's a certificate authority, and finally there's an orderer. So quite simple, quite straightforward. So that's the basic network. Another network I keep using it is the first network. And I mean, in the tutorial, you probably see that bring your first network. And in fact, this is the first network. You can see it's more complex than the previous one. You have still one orderer organization, but now you have two organizations for peers. One Odd1 and another Odd2, and each organization have two peers, peer 0 and peer 1. And you probably will see that I have some dotted component there. And so it's a well-state and also the CA. In fact, you can turn it on, I mean, as an option. I mean, if you just run it by default, it's not there. But if you put some options in the BYFN script, you can bring out the CA and also the well-state. And by the way, both basic network and first network come up with a channel. The channel by default is called my channel. So in this diagram, you probably will see that all the two organizations, all the peers are joining the my channel. So they are sharing the I mean in the same channel. So this is the first network. As I mentioned before, you can see two peers from Odd1, two peers on Odd2, and one orderer. So again, you can just go to there, with this command, you can run your, first network quite straightforward. So in fact, there are some more complex networks in real life. We don't just use this tool for production. So in many cases, you may need more channels, multiple channels, or you need to deploy it in multiple physical nodes. Because all the demonstration nowadays we build are all running on my local host or a Linux server. So in that case, it's good. Everything is running on the same host, but in reality, you have to put them into multiple hosts. In fact, not just multiple nodes or multiple hosts. In fact, you probably will deploy in different data centers, like some nodes in your data center, some nodes on AWS cloud, some nodes on Azure cloud. So in that case, the network will become more complex. I have tested some setup and documented in my articles. Later, I will share with you those articles where you can find those sample setup. So this is the network part, the infrastructure part. The good things on Hyperledger-Fabric is that the application you build, like the chain code, you can run on different platforms. You can test it on basic network, test it in first network, and finally run in your own networks. So that is the beauty of breaking the application, breaking the blockchain platform into two, infrastructure and the application. So after the infrastructure, we just put it aside because today I'm more focusing on the application part. So we will take a look on the two parts inside the application. One is the chain code, which is running inside the infrastructure. This is quite interesting. The actual chain code is running inside the peer. The other one is on the application, which is the client application using the SDK accessing the Fabric network. So then, nothing is better than I use a real example, that is the Fab car, to show how these two parts, the chain code and the client application, work together. So first, the Fab car again is coming with the Fabric samples. You will have it once you install the Fabric samples, everything. So Fab car, in fact, I would say it is a very simple application. It's nothing more than a database. That database is keeping the car records. So later you will see that in fact they have a data structure like a table, the name, the model, the color, the owner. And then you fit in those information one by one. So it's nothing more than like a database. In fact, you can use a SQL database doing almost the same thing. So this is one thing. The second one is and also the Fab car is composed of, as I said, all applications in Hyperledger-Fabric is composed of two parts. One is the chain code, which is running on the infrastructure. Another one is the client application accessing through the SDK. So the Fab car can be deployed on every Fabric networks. In fact, at the very beginning, Fab car was deployed on the basic network, and now the example since 1.4.3, they move it to first network. So that's why you will see the first network. So let's take a look on the chain code first. This is the chain code structure. I'm using Golang. I'm not a programmer, so I'm not good with Go or JavaScript. But Golang is quite straightforward, so I just use it as a sample. I check with JavaScript, quite similar. So once you understand the structure of the the chain code in Golang, you definitely will understand how it is structured in the JavaScript. So inside the chain code, there are several parts. We will take a look on it. One is the data structure. One is two big functions called init and also invoke. And under invoke, you will have a lot of actions, commands, queries. Then you will be part of the invoke. So I would go through the data, the chain code that from the Fab on Fab car. So the first one is the data structure. As I mentioned before, it's nothing more than a database. So you can see, from this, even you don't know Go, you probably can tell. It will be a JSON, with information like the manufacturer, the model number, the color of the car, and finally the owner of the car. So this is a basic structure. Of course, there are you can for some complicated chain code, you will have a lot of data structure. But in this case, this is just like a basic, simple database. So the other two major functions called init and invoke. The init one is when you instantiate your chain code. This part of chain code will be executed and will be executed only once. And after you instantiate your chain code, the code is executing. The code is executed, and it won't be executed anymore unless you update the chain code later. So the init in this case, you can see it is nothing. So I mean, based on the fab car, you don't need to put anything on the init. So when you instantiate, you just keep an empty argument. That will be good enough. So the most important part, in fact, is on the invoke. Invoke is how you interact with the chain code once you deploy it, once you invoke it, once you instantiate the chain code into the network. So in general, it is in a structure like this. The invoke will come with the two, arguments. One is the function name, and another is the argument list. That argument list is used with inside the function. So this is quite straightforward. I see almost all the chain code are keeping in this structure. So within the this structure, you can define as many functions as you can. Say, for example, on the fab car, they have defined 5 functions: query car, init ledger, create car, query all cars, and change car owner. So these are the functions created for the fab car application. Of course, you will have your own set of sub-functions based on the use case on your side. Later, when you see the invoice finance, you will see I have 3 functions defined by myself. So this part, you will define the function, and in fact, once the chain code identify you are asking for query car, they will call a function inside the chain code. And this is a query car, init ledger, create car, query all cars. They are all defined as sub-functions. So these are the sub-functions. You need to define your own logic. For example, for query car, you have to specify the car ID, and then they will return the car record for you on that car ID. If you are change a car owner, you need to provide the car ID and the name and the new owner, such that it will change on the ledger. So these are the sub-functions you need to define one by one. You probably will see that I collapsed them. I just let you take a big picture to see, how it looks like. And then I take 2 examples. For example, the query car, as I said before, quite straightforward. I will check whether the argument is, the length is 1. That means I only need a car ID. So with the car ID, the chain code will get the state from the world state and return the result for you. So very straightforward. The query car just return the information based on the car ID you input. And for create car, more complicated, because now you are not just query something, you in fact add something on the ledger. So in that case, beside the car ID, we need the manufacturer, the model number, the color, and also the owner. And then everything will be put into the ledger again. So after that, we just return nothing. That is how the chain code looks like. I just showed this too. In fact, you can imagine there are one for init ledger, there's one for query all cast. I just leave it as an homework for you. You can try to take a look on the chain code inside the fabric samples, and roughly you understand the structure. You can read the chain code how what actually they plan to do. So these are the 2 functions. And when you try to deploy the network, you can go to the FabCar start script shell. And today I try not to run this, although I do it almost 3 or 4 times a day. The idea is the script will build up the first network, and then bring up all the containers, the Docker containers, create and join peers into the network, the channel called my channel. Install the FabCar chain code on each peer. We have 4 peers, so you can see it will install one by one. And instantiate the FabCar, as I mentioned before. The instantiate, you will run the init, but again, there's no init in our chain code. So there's nothing happen. After instantiate that. And finally, you can do a lot of chain code info and query on this application. So in this case, they will run the init ledger first, because it come up with 10 data. So so this is the after you run the init ledger, there are 10 records pre-populated into the database. You can see what we mentioned before: the car ID, the color, the manufacturer, the model, and finally is the owner of the car. This is pre-built, and you can change it everything. I mean, it's quite straightforward. I just let you know that after you run the init ledger, you will have these 10 records on your well-state database. So this is, I just try to show some command line interface and how it looks like, how complicated it is. So I try to invoke one function that is called, let me take a look on this, create car. You can see the final item. Let's start with the final item first. The argument I'm submitting to the CLI is I'm calling the create car function with the car ID, the manufacturer, the model, the color, and the owner. And before that, you probably will see a whole bunch of parameters in that. Just do a quick check. So it is a chain code invoke command. We need to specify the orderer, although they have some default. I try to use the orderer, and since the orderer we have TLS enabled, I have to submit the root certificate for the orderer. So just make sure that I'm using the right. I have the right to access the chain code, and I need to specify my channel. So minus cap C is the my channel, and the fabric. The chain code name, FabCar. So the peer address is, since the endorsement policy requires two components or two peers, so I need to specify this proposal will be sent to peer 0 odd 1 and peer 0 odd 2. So this is how complicated when we use the CLI command. You won't type it one by one. I just copy and paste. So don't worry, you don't need to remember everything. So if everything looks good, I will get back to chain code invoke successful, result 200, but no response. Why? Because if we take a look back to my chain code for create car, there's no return, so just nil. But everything is now written into the ledger. So this is how once I invoke the chain code with the command line. So once the invocation is complete and successful, we can use a query that is query car with car 12. In fact, car 12 is what I have added in the previous invoke. So when I specify query car as my function and car 12 as the argument, then the ledger will execute the chain code I showed you before and return the actual data from the ledger. So the color, the manufacturer, the model, and the owner. You can see it is exactly what I have added previously. So this is how to use the command line interface to do the invoke and query. But don't worry, you won't do it, every day, because it is more on chain code development, testing, bug fixing. You will use CLI quite a lot. In real life, you won't use CLI. But CLI is good for demonstration, and that's why if you read my articles, I keep using the CLI to do the demonstration. So once you have the chain code and use the CLI, test all the functions are happy. You are happy with all the chain code you develop, all the functions running. So in this case, we will move to the client application. So that is the upper part. The chain code is on inside the network. So the upper part is the client application, which is external user, in fact, are interacting with this client application. And this client application will use the SDK talk to the Fabric network. So there are two steps when you are using the client application. First, you have to enroll an identity for client application. Remember, blockchain Hyperledger-Fabric is permissioned blockchain. That means every user, every node has to get his own identity before it can use the network. So when you use the client application, you have to first get an identity enrolled, such that you can use it for the next step, which is interacting with the train code function. So we will take a look on how it looks like. But before that, inside the client application, basically there are 5 parts. First, it's quite straightforward, right? The first 3 are loading things into the client application. So we need the SDK, the software development kit. We need the configuration profile. Interestingly enough, nowadays, you have to tell the client application where to go, where to connect. That means I need to let them know, okay, which fabric network I'm talking about, which channel I'm using, and which chain code I'm invoking. So in that case, you need to provide a configuration file. The configuration file is more on the infrastructure side. I mean, the network node, the peer node, the orderer, the certificate authority, etc. So then you have to load the wallet. That is the identity you enrolled before. So you have to make sure you got the credential before you can access the client application. And then you can specify, I mean, what fabric network chain code you are using, you're going to access, and finally, the chain code function. So I code 2 examples, then you can have some idea. So the 2 examples is from FabCar, JavaScript, query.js, and invoke.js. Sorry about that, because I tried to put it into a slide. So it seems it's quite packed, small, but once you have the slide, you can have a more detailed study. But I try to let you know that, I mean, which part is what. So the first part, you can see we load the SDK, that is the required fabric network. The second part is connection profile. The connection profile is called connection all1.json. In fact, it's available on the first network. So once you go into the first network directory, you definitely will find this component, this file. And inside the file, you can see, okay, my peer node IP address, port number, my orderer IP address, port number, etc. So this is the connection profile. You need to specify it where the client application can grab those profile information. So this is the second part. The third part is the wallet. And you can see that both query.js and the invoke.js, in fact, both have the wallet. They are using the user one. The user one will be, we will enroll the user one before running these applications. But let's go into the application first. So we can see that this is the user one, load from the wallet directory. Once you have all these 3 together, you can go into the live network. So with the live network, I can specify I'm accessing the channel called my channel and the chain code name called FabCar. So these are everything you need to tell the client application before they can really do something for you. So you can see it seems it's quite big file. I mean, I won't say big file. You can see 50 lines, not very large. But at the end of the day, you have to specify this information before finally you can use the actual chain code function. In this example, you can see I'm using the query or cast. So later, when I type the query.js, you will see the result. I mean, all the car records will coming up. So this is one example, the query.js. The second one is the invoke.js. You can see very similar to what the query.js. The only difference, I have to say, that is the last part. Is the actual function you wish to invoke. I mean, on the chain code. You can still see the load SDK connection profile, load the wallet user, and specify my channel and also FabCar. And finally, for invoke, is submitting a transaction which is again called create car. It's quite familiar, right? I mean, you have the car ID, the make, which is the manufacturer, the model, the color, the owner. So once you specify which function with the argument list, you just submit that, and everything will be done by the SDK for you. So compared to the CLI, you can see it's much easier. I mean, what you need is just change this function. Like, in fact, they have some comment here. If you wish to change it to change car owner, you just use change car owner and the car ID and the new owner, and that's it. So it is how easy it is. I mean, when you develop, I mean, client application using some example on FabCar. So I just try to show you some screenshot how to run this. Now you can see I'm not on the CLI. I'm on a script. So since I'm using a JavaScript, so I'm using Node.js to run this. And remember, we need the identity. So the FabCar also come with two files. One is called enroll admin. One is called register user. So these two help you to enroll user called user1 with the private key, the public key, and the certificate inside the user1. You can do it by yourself. I mean, as a practice. But just let you know that, I mean, it is how to create the user1 here. So once you have the user1, you can invoke the chain code. So now you can see that I can just simply run node invoke.js. This file, in fact, is doing something we mentioned before. It just create a new car with this record. So after the execution is completed, everything looks good. You will receive something like a transaction has been submitted. If you are listening to the event, you probably will receive the event from the peer saying that, okay, the transaction is already included in the block. So, but now here, I am not showing this. So you can see that after the invoke, I run the node query.js. Interesting enough, now we have this new record where it is, okay, this is the new record. You can see the car 12, the color, everything. It's just exactly what we have we have done before. I mean, in the invoke.js. So again, you can build your own application one by one based on the requirement. You can just simply modify the chain code function, and what's nice is this parameter now is quite, I mean, not very professional, right? I mean, it's hard coded into the code. In fact, you can make it like a parameter passing from the command. So for example, if I am using node query car 0, then you will just return the car 0. Car 1, then you just return car 1. Everything is doable. I mean, as far as you just modify this JavaScript file. So this is how client application looks like. So one of the most common questions, I mean, from when I visited my client, they always mention that, okay, do you have an API, a standard API such that external world can access the API instead of using, I mean, building the components one by one. So the interesting part is Hyperledger-Fabric seems they do not have this standard or a sample API environment. So in this case, you have to build something by yourself. So what I have, I mean, recently is a Fabric node, which we have a first network, a channel, and a chain code. Then you can build a API server node here with many tools, and I just use Express.js as my script. And with that, I can specify those API. I mean, like post new car or get query and car 01. So in that case, you can define your own JavaScript. And once you have this server node up and running, you can build anything outside. I mean, just calling some standard REST API. I need to highlight one thing is that since, as I mentioned before, we need an identity. So the identity currently, the easiest way is to put it into the API server. And also we have the connection profile to let them know that, okay, I am connecting to this network with this channel and this chain code. So in fact, I have an article talking about this, and quite many people like this article because you can follow the step, and once you have the FabCar up and running testing, you can build your API server node, and later you can do whatever you like. I mean, you can build your mobile app, you can build your web application. I mean, since they are all in basic REST API interface. So this is how a client application looks like in FabCar. So as a summary, I always use FabCar as an example, in particular doing my testing and some proof of concept, because it provides both the train code and the client applications. With this tool, I can show what should be inside the train code, which is the business logic, what should be outside the train code, which is more the customer facing, what functions you wish external world can access your network. So in that case, and one important thing is the train code itself does not have any fabric information, fabric network information. If you don't mind, I'm just go back a little bit. Sorry that that may have your screens scrolling. If you look back on the train code itself, the interesting part is you don't need to define my channel. You don't need to tell them the name is FabCar. This same logic can be used on basic network and the first network. So you can use it here and you can use it there. And you just develop once and deploy the train code everywhere. I mean, that is important because you don't need to revise, the train code if you modify the network network infrastructure. Nothing is included in the train code about the channel, about how many organizations you have. No, you don't have that. You just have the function you define. But after that, in the client application, I have to scroll way back. Sorry about that. I'm skipping the screen. So once you have the train code ready, the client application, in the client application, you have to tell them the actual channel or the network, which peer node you wish to connect. In this case, they are all in the connection profile, as I showed you before. And once you have both the client application and the train code ready, then you can evoke or query those train code functions. And last but not the least, quite important, as permission blockchain, you have to get an authorized user before you can access the network. And that's why you always have to enroll an identity from the certificate authority before you can do everything. If not, you probably cannot run any command like invoke, like query. So this is how the FabCar looks like. So after that, this is a good example, as I mentioned before. You can see the train code, you can see the client application. Then I try to apply it into another use case, which is I call it invoice financing, or sometimes you may call it a trade finance. I need to highlight one thing is, over the experience I have so far with the clients, if you wish a blockchain project successful, it's much better it is a consortium blockchain rather than a single blockchain that is, just one company owns it. Remember the FabCar, right? There's a database. You can imagine that, okay, this is a database owned by one company. So it doesn't make sense, right? And well, I won't say I should not say that. It is not as good as we are using it in a consortium environment. So in a consortium environment, there are more than one business entities. They are working together. They wish to achieve a business objective. That objective must be good enough. They are willing to join the consortium network. So the consortium can be formed by business partners, like supply chain, right? The producer, the shipment, the bank. So they are step by step, right? They are business partners. And sometimes, in fact, even business competitors can join the consortium. As far as the value of the consortium blockchain application can bring to them, much, much bigger than, the competition. And in fact, the example I'm showing you, the trade finance, the invoice financing, is one of them. In the market, in fact, there are a lot of consortium formed on trade finance in general. So trade finance in simple word is financing the trade. That means you make some loan or borrowing some money for some trading business. You can see that in this slide. In fact, there are 7 consortiums formed, and if you zoom in it one by one, you see that most of them are banks or financial institutes. you can see how come those banks supposedly are competing to each other, right? I mean, the HSBC won't like to share the customer to Wells Fargo and vice versa. How come they wish to join the finance a consortium network? It is because with this network, they solve some problems they faced before. So in this case, I pick up one simple example called invoice financing. For invoice financing, the banks encounter some challenging, in particular when they are doing real business. So what are the challenging? So in case, I mean, those attending here, there are some business people. I know that you know more than I, but I just try to make some simple introduction on what trade finance means or invoice financing means. So supposedly, Alice Software House is providing a service to Bob. Bob has a shop and they need a software. So Alice bill for them, and after everything is done, Alice will send an invoice to Bob saying that, okay, this is the amount of money, 10,000. And you see that usually it comes with a time which is 30 days. So that means the Bob shop can pay Alice within 30 days when Bob received the invoice. So we call it the credit terms or sometimes just term. So the payment is in term. That means Bob does not need to pay directly back to Alice immediately. It can just wait for, a month, 30 days. Then as long as Bob pay Alice back, within 30 days, everything is still okay. Alice is still happy. So this is a very simple trade flow. We keep seeing this every day in our business life. What happened is Bob has not paid Alice yet, but Alice needs some money. So in that case, Alice can use the invoice as a collateral or as a proof to a bank Alice Software House is working with. And the bank will, based on the invoice information, make sure it's a true invoice, the amount of money, 10,000, okay, I can expect, I loan you X amount of money for a month. Once Alice get back the money from Bob, she will return the money back to bank plus some interest. That is how the invoice financing is working nowadays. So this is a very straightforward one. Again, it's not new one. It happens every day, every second, because the business is running or operating at this stage. So the double financing challenge is when Alice Software try to loan or borrow money from two banks. It's quite interesting. From the bank Alpha or bank Beta in this slide, you can see that they don't know whether the invoice is being used before or loan some money from a bank before. So in that case, bank Alpha see the invoice, okay, I loan you this amount of money. Bank Beta, okay, get your invoice. Okay, supposingly the bank Beta trusts Alice invoice, and then it just loan some money to Alice. Then Alice, this is what we call double financing. Double financing is not desirable by the banks because there are some risk that the bank may not get back the money. So this is one problem. Another big problem is maybe the bank Beta are willing to subfinance an invoice, but the amount, the bank Beta has no idea how much money bank Alpha has already loaned to Alice. So in that case, Alice may get back the money which is more than the actual invoice amount. Remember, we have $10,000 on the invoice amount, but finally she may get back 15,000. So in that case, it is a risk to the bank again, because some bank may got some problem. The bank may not get the money back. So this is, we call it either double financing or over borrowing issue. So what's the reason behind why they happen? It is because bank Alpha and bank Beta, they are not talking to each other. They are competitors. They won't share information to others. So this is how invoice financing coming up. So this is just, just exactly what I have mentioned before. But thanks to distributed ledger technology, that is blockchain we usually use, it provides a good mechanism to reduce this type of risks for the banks. So we try to build a blockchain application with the invoice financing. So first we design the chain code. Then we build the bank network, because I mean, this is the network we need to build. I'm using, you can see the bank network later. And then we're simulating those demo case, how it works. So let's take a look on the chain code and the bank network. So the bank network is look like this. Again, nothing fancy, right? I mean, it's almost the same as the first network we used, but I changed the name from OP1 to Alpha, from OP2 to Beta. And we have the certificate authorities for each bank. So the bank network. Now you see just 2 banks, right? I mean, in general, there can be more than 2. You can see there are, I mean, 10 banks or 12 banks in some consortium network. But for this demonstration, I just show that this is just 2 banks. Once we have the bank network, we will deploy the business logic, which is the chain code, on both in all peers. In fact, all peers will have the chain code installed and instantiated as well. So the chain code, again, you can access my GitHub to get all this code, because I uploaded on the GitHub, and I have an article have more detailed description, but I just try to extract those information. So for the data structure, it's easier than FabCar. I'm just using two data to record the number. One is the invoice amount, something like the $10,000. Another is the borrowed amount. How much has already been borrowed or loaned out to on this invoice? So these are the invoice data structure I am using. So it is the value, and the key, I'm using the company, which is Alice, and the invoice number as the key. So every company come up with an invoice, then we will create a new entry for them, keeping those records. For the init, again, I mean, nothing, I don't need to do anything in it as when the chain code is instantiated. But for the invoke, as I mentioned before, you can define whatever you like, the actual functions. Now I have 3 functions for my application. One is init invoice. Second is request loan. The third one is query invoice. From the name, you probably will know what I'm doing, right? For init invoice, it must be a brand new invoice joining the bank network. Request loan is on existing invoice. I wish to make some money, borrow some money from the invoice. And finally, we allow the chain code to query the invoice. What is the latest information about the latest status of the invoice? So this is the data structure and also the function I define. You can see it's quite simple, even simpler than the FabCar, because I just have 3 functions. What's important is inside each function. So you can see I have the init invoice, request loan, and query invoice. So let's go take a look on it one by one. So the logic, again, I'm just highlight the logic, not line by line. The first part is I need to make sure you are coming with the correct argument list. So what I'm asking for is the company name, the invoice number, and an amount is truncated in this slide. So you can see company invoice and the invoice amount. So this is what I need. If you're missing some components, some arguments, then I will just, return an error saying that, okay, incorrect number of arguments. So this is a good practice to let other nodes know what actual parameters you are using. So after that, I need to check whether the invoice amount is an integer, because everything passed in the when you invoke the chain code. In fact, they are all in string. So ideally, you can check whether I'm passing an actual number. So this is how the logic doing. It's quite straightforward. I mean, converting from string and back to and convert to integer and see whether there's some error. So again, I just copy it from somewhere. No rocket science here. So make sure the invoice is an integer number. And thirdly, we construct the key. As I mentioned before, the key is from the company and the invoice. So you can see the company and the invoice. I just put a dash to make it, readable. So the key invoice key is company dash invoice number. And after that, I just put those information back to the ledger. But before that, the most important part is here. If this invoice is found, that means this invoice key is already recorded on the ledger. We will get back with an error. This is to avoid double financing. You can see the demo later, but the how we check whether an invoice is being recorded or not, we will see whether it's already inside the ledger or not. So if we find this ledger already recorded, you try to init it again. So I would say that, okay, this is a problem. So this is how the init invoice works. So from you can see this is an illustration. Once I pass the invoice with the company name Alice, the invoice number called invoice Bob 001, and the amount is 10,000. This will be recorded in the ledger. And you know Hyperledger-Fabric, right? I mean, every peer node will keep their own world states. So everyone has a copy of this information. Lovely. So everything. So once you init, no matter it's from bank alpha or bank beta, it will already inside the ledger. So the second function I have created is called request loan. The request loan is executed when the invoice is already in the ledger. So the first thing is okay. Let's start with the argument first. So again, we are requesting the company name, the invoice number. This time is the requested amount. So not the invoice amount. The invoice amount is already recorded in the previous function. So in this function, I'm requesting X amount of money from against this invoice. So again, we check it whether it's integer or not, and construct a key. Make sure the key construction is the same. Then everyone will read the same record. So again, this is how we check first is if this invoice is not initialized yet. That means if I see no record on the on the ledger, that means you have not done the init invoice. So you need to do this first before you can execute the request loan. So this is just make sure the record is there. And this is how we protect against over borrowing. We will check whether the invoice amount and the borrowed amount. If you are asking for amount more than the difference between the invoice amount and the borrowed amount, that means you are over borrowing. So in that case, we will return an error saying that, okay, amount requested exceeds the credit limits. If not, we just add that amount into the borrowed amount because you are borrowing more money on existing environment. And after that, you just save it back to the ledger. So this is how request loan like. If we put it into, again, the illustration, you can see that the request loan, Alice invoice Bob 01, these two must be the same. This time I request 7,000. In general, you won't request 10,000 because no banks are willing to loan you money with that big amount. I mean, you probably must have the amount lower than the invoice amount. So in that case, if I'm requesting 7,000, the 7,000 will be updated into the ledger. And now you can see that for the record, this is the key, the invoice key, company name dash invoice number. This is the invoice amount, 10,000. And now 7,000 has been loaned to Alice. So this is how the record is seen by all the peers, by all the banks inside the bank network. Okay, so for query, I mean, it's more straightforward. Just make sure you put it, you input the company name and the invoice number, and I will get back to you. So query is not very challenging. There's no business logic in the query. Just return the what's inside the ledger. So this is how the chain code, the design. So again, as I mentioned before, when you develop an application, the most important part is you need to understand the actual logic. The actual logic. That is, what are the functions you need to interact with the ledger, and also the ledger, the data structure of the ledger. I mean, what record you wish to keep inside the ledger. You should not keep everything inside the ledger. That's important things. For example, shall I put the which bank loan which amount of money to in the ledger? The answer is no, because remember, the bank networks, they are competing to each other. When they are competing to each other, you don't wish to disclose too much information about the loan in the ledger, because everyone can see it. So in that case, we try to minimize the information recorded inside the ledger. In this case, I just the invoice amount and borrowed amount and nothing else. No interest rate, no expire date. So this is when you design the chain code, I mean, this is very important. And finally, you don't need to define 10,000 of, functions. You just define those you need. Then, then the application will be very clean, very good, and fulfilling what the business goal is required. So this is how how I design the chain code based on the case I'm using. So the next part, I try to get into the chain code invoke using the SDK. So again, since I'm using SDK, remember we need the user identity. In this case, I am creating two sets of user identity, one for bank alpha, one for bank beta, because I wish to show, bank alpha do something and then bank beta do something. So it's so again, for simplicity, you can see that I just have the function called init invoice, request loan, and query invoice. But I just put a bank as which bank are initiating this, like init invoke alpha, init invoke invoice beta. So this is how I'm designing. So again, those scripts are all in my GitHub post. You can take a look on what how it looks like. So the demo flow is quite straightforward, right? I showed it before, but I just make it more like a story to see how it works. So Alice, as the software company, holding an invoice, this invoice with the amount 10,000. Alice tried to apply for loan from Bank Alpha 7,000. So this is exactly what we see before. But after that, Bank, of course, record this loan in the bank network. And Alice tried to use the same invoice to make a loan on Bank Beta. So Bank Beta will immediately find that this invoice is already inside the bank network. And after that, there are three possible results. So the first possible result is the bank beta may reject the loan because I don't like double financing. Since you already loan something from someone, I just reject it. So this is one possible case. The second possible case is bank beta may allow double financing. Okay, because bank beta may be a good friend with Alice software company. Okay, even you have already loans from some companies, I still loan some money. So Alice saying that, okay, I need 5,000. So 5,000, what happens is that the 5,000 plus the 7,000, it will be more than 10,000 already. So it's over borrowing. So check this loan application. Bank beta, although we are friends, right? But I don't want to run. I don't want to lose money in your. So bank beta just reject it. Or finally, and the last scenario is bank beta allow double financing, and Alice saying that, okay, since I already got 7,000 from bank A, bank Alpha, I may request just 2,000. Then the amount, the summation of the two amount is still below the invoice amount. So bank beta, okay, approves it and get an updated ledger. So this is how the flow looks like. So the first thing is let's bring up our bank network. So the bank network, as we showed before, we have the bank beta and bank alpha, two peers on each bank, and certificate authorities for both. and orderer. So this is a very simple network that I showed before. If you have a real production environment, you may have a lot of banks inside, but here I just have alpha and beta. So the user alpha, that is maybe the clerk in bank alpha, or maybe the teller, she will submit the request like init invoice. Alice invoice, the number, and also 10,000. So again, everything is recorded into the in the peer. So this, I mean, the init invoice work. And if I use the string code, if I use the script I created, again, it's in JavaScript. I use Node.js, and this is the function name, the script name, init invoice alpha dot JavaScript. The .js file. This file again is in the GitHub. So the company is Alice. This is the invoice name, and this is the amount of money on the invoice amount of money. So after the transaction is submitted, processing, everyone is happy, no error message. If we try to query invoice from Alpha, Bank Alpha, on this invoice, company and invoice number, we will see that, okay, we found this, and the invoice amount is 10,000, which is here, and borrow amount is set 0 because no borrowing happens yet. It's just an initialization, not no amount of money is requested yet. So the second step is, okay, since Alice is asking for 7,000, so we submit a request called request loan. This is the invoice number 7,000. Since 7,000 still less than 10,000, so the approval is okay. The ledger is updated, so you can see the ledger now from 0 to 7,000. And this is the command we are using. The node request loan alpha. Again, the same. This name must be the same, otherwise I cannot find the actual record. 7,000. So if I query again on this invoice number, the invoice amount, no change because the invoice amount is already initialized, but the borrow amount is 7,000. So in the record, I know that this invoice, 7,000 is already loaned out. I mean, against on this invoice. So, I mean, Alice tried to go to bank beta and do something similar. So first, they try to say that, okay, I wish to loan some money on this invoice. So when this invoice is submitting, since the company name and the invoice number is the same, that means bank beta will immediately find that, okay, this record is already in my ledger. So the record is found. If bank beta does not allow double financing, I mean, the borrowing process will stop because bank beta found that it's already loaned by someone. So that's how we use init invoice again, but this time I'm on behalf of beta using the beta identity. Again, the company name, invoice name, and the amount of money. So you can see record found for company Alice and invoice involved Bob. This in fact, you can see there are 4 messages coming back. Why there are 4 messages? In fact, every peer coming back with 1 error message. So you will see 4 here. I mean, if you do some good programming, you can hide them, but at least you know that there's something happened. Bank beta has found this invoice is already in the ledger. So the execution is failed, the endorsement has failed. So this is one scenario. It just stopped. But in case bank beta, okay, I accept double financing. Okay, so how much money you wish to loan? I mean, Alice say that, okay, 5,000. So in this case, when 5,000 get into the network, we will check whether the amount, the total borrowed amount will exceed. You can see immediately, right? I mean, 5,000 plus 7,000 will be 12,000, more than 10,000. So it's over borrowing. So again, bank beta say, no, we cannot give you this amount of money. So you can see I'm using request loan, but this time it's from beta. The same invoice company invoice number, and this time we are requesting 5,000. So with 5,000, you can see the error message. Amount 5,000 requested exceeds credit limit. Who gave this message? I wrote it in the chain code. You can get, scroll it back, you can see the chain code. I have to test if it's exceeded. I'm return this amount, this error message. So again, the endorsement failed. The ledger is not updated because, the borrowing has not happened. So finally, if Alice say that, okay, I just request 2,000. In that case, the amount of money still, the total borrowed amount is still less than the invoice amount. So in that case, the bank beta accept it and update the ledger. Now the borrowed amount become 9,000 because it's 7,000 plus 2,000, so it's 9,000 now. So if the request loan beta this time I'm requesting 2,000, then we query again, and the borrow amount now is 9,000. So this is the whole flow or the idea how the invoice financing works. Again, I would say that this example has much higher value than the FabCar, because FabCar is just a database. But this type of application is, we are talking about a business network for banks. Banks are competing to each other. But with this network, this application, in fact, largely reduce the risk the bank are facing. They don't know each other, right? I don't know whether this invoice is being used or not. So if there's such a network, it definitely can help, the real business. And I always encourage my clients, if you are looking into blockchain solution, the first thing is whether your business case is, a consortium environment. Because if it is a consortium environment, blockchain definitely play an important role. If it is not a consortium environment, say if it's just a single company building a database, well, you still see some value on that. But people will challenge you. You can use MySQL database or Oracle database, then you can achieve similar results. But in such a consortium environment, like multiple banks, Bank Alpha, Bank Beta, Bank Gamma, in fact, they cannot share MySQL database. They have to rely on platform like Hyperledger-Fabric to build this application on a network. They are part of the network such that they can get the value from this application. So this is how I always don't do something like what we call blockchain for sake of blockchain. Because I need blockchain, then I wish to do something on blockchain. No, it should start with a business case. That is the real business case. Then makes sense on blockchain environment. Then you can design. You can start. Doing the design, the actual coding testing environment. This is more helpful. Or more healthy. I would say that. In application development. So this is what I share about the FabCar and also the invoice financing that I prepare for my demonstration for proof of concept. And as a closing, I try to share with you some experience so far I have in the building application on Hyperledger-Fabric environment. So the FabCar itself, I would say it. We have taken a look on the Hyperledger-Fabric network. The first network, and also the FabCar application one on top of it. FabCar is nothing more than a database recording on the Fabric network. It's helpful, compared to a single database, because the data, we always say that immutable. I am being conservative. I have a reservation saying that it's immutable, but at least any tampering on the data can be easily detected. Because you still know that, right? The blockchain, anything changed on one chain will have void on other part. So the data tampering protection is here. And every transaction, in fact, is recorded on the blockchain. That is true. And you can trace it. You can audit it. When business is requires you do so. So every transaction, you try to add something, I can always trace out, okay, when you do this, who is the signer, who record this. So everything is in the record, in the ledger. And resilience, since you will deploy the ledger on multiple sites, right? I mean, although it's owned by one company, you still prefer to have, I mean, one node in your data center, one node in AWS cloud, one node in somewhere else. So in that case, there's a certain level of resilience. If some node is down, being shut down, you bring it up, then you can still get back all the data from the network. So data resilience is another value. But again, these are some people will challenge you saying that, okay, there are some expensive database can also have this features. So I agree with that. So that's why I always saying that blockchain projects should be a consortium project, not a single company project. So this is what I mentioned before. Do we need a blockchain? So if the application is multiple organization, definitely, I mean, the keep a copy of data, and also I trust that data is very important for individual organizations. So in that case, we definitely need a blockchain platform, and in particular, like Hyperledger-Fabric, that is the good candidate in this type of multi-organization applications. But if the application is just wholly owned or deployed by within one organization, the value is not as good as before. I mean, as I mentioned before, it's like a database, and because within a company, no one challenge your trust, right? I mean, you won't. The boss will trust you. I mean, the department will trust another department within a company. So in that case, always ask, do we need a blockchain? And to be honest with you, I have visited many companies, and I have to find that 2/3 of them, in fact, they do not need a blockchain. They just need a database. So I always educated them. I mean, in what scenario you need a blockchain. So for the invoice financing, we have the invoice financing case. It is a consortium blockchain. You can see even the banks are competing each other. They are still willing to join this network because they find the value. It benefit to their actual business. That's why they are willing to join the network. It's not easy. I have to say that. I mean, finding a use case that every parties are willing to join is always not easy. And that's why you still don't see a lot of blockchain projects at this stage. The most successful projects in the market nowadays are like supply chain, like the in-trade finance. And you can see these are more like, I mean, they are willing to share information and they can benefit from the application. So, but the ultimate bottom or the foundation of such network is that those participating banks or companies, they need to trust the system. They won't trust the database installed on your environment, not on my data center, right? The good thing is everyone has a copy. Everyone has a node on their data center. And they will keep a copy of the data, and they trust the business logic, like the one I showed before. If it exceeds the invoice amounts, the network will say no. They trust that business logic will automatically execute it. And that's why they are willing to join this type of applications. So some general guideline in application development. Again, just share my experience. There's no rule of thumbs. You see many companies, they may have different idea, different approach building blockchain application. But over the past 2 years, when I share with my clients, there's some ideas I like to share with you. So the very first one is it a sound business case? Don't try to build blockchain projects because of blockchain. Although I know blockchain is very encouraging. I mean, I'm a techie. I like blockchain technology quite a lot. But if the business case is not sound, that means, okay, in fact, you can use a database instead of using a blockchain. So in that case, don't try to spend too much time on the blockchain. It's not easy. You probably know that. I mean, it's quite complicated. But always ask, do we need a blockchain? But once we confirm that's okay, yes, this is the blockchain we need, we start planning. And the planning part, there are two parts. One is the network. How I try to deploy the nodes across the network. Is every companies have one peer or two peers? Do we have some regulators? So you need to define the actual network, how it looks like. how many peers do they have? I mean, who are the certificate authorities? Who are running the CAs, etc. So the network part is quite straightforward. I have to say that because I mean the network 10 companies, you need just 10 organizations. 12, you just need 12. So quite straightforward. So the application part, the blockchain application part, again, is the chain code. That is the business logic written and executed inside the blockchain network. And then the client application, which is the user front end to accessing to your environment. So this is some general guidelines. And finally, the chain code structure more or less is fixed. And all the chain code I wrote so far is copy and paste the structure. And then you just design the actual logic. Like the invoice financing, I have 3 functions. The Fab card has 5 functions. I see some application have 10 functions or 20 functions. Quite complicated, but this is, I mean, depending on the business needs. But more or less the structure is fixed. Once you have that structure, you can develop your own, and you can easily read others' chain code. Always learning is from copying or referring others' chain code. And from my GitHub, you can find several chain code pattern, and then you can build your own based on your actual business need. So the structure itself is important. The function itself, I mean, how many functions, what functions you need is up to your real business case. But the structure itself is quite straightforward. I would say it's almost fixed. And finally, once you complete your functions, test it in a simple network, like the basic network. I like the basic network quite a lot because always very easy to find out problems, then I fix it. And you don't need to build the whole network before testing your chain code. You don't need that. I mean, Hyperledger-Fabric is good enough. You build something on one side and build something on the other side. And finally, you can deploy the same chain code running on the basic network to the real network that you are building up. So this is how some general guidelines for you. So for those, this is the material I prepare. Today, I just as a web app, I just try to share with you, I mean, some experience in blockchain application, in particular on Hyperledger-Fabric. I share with you some Fab card, the Fab card details, and also use case that I developed for one of my clients. And for those who wish to follow me, I mean, you can find my LinkedIn profile here. And as I mentioned before, I keep publishing articles on my Medium page. And in fact, I have creating my small website. And for those who are interested, this is the how I mean the one page. I try to include all my articles. So you can see that for Hyperledger-Fabric, I have quite many. So you can see the Fab card, you can see how to add organization, how to remove organization. These are just my practice. I just documented them. I hope in case you find something useful, you can make a reference to see how I can create a configuration file, deploy something. For the invoice financing, I have put it into blockchain application, so you can see that there's invoice financing application, Hyperledger-Fabric blockchain. So in fact, the link will go back to my Medium page. Just let you take a look on. This is my Medium page, so you can always refer to what I have mentioned before. Everything is almost identical here, so I just try to use it to share with you. So finally, if you wish to, this is the my article collection, so you can access it, and then you can. Oh, by the way, last but not the least, in case you have some interesting questions or use case you wish to know whether it works or not. It's not commitment, but I always would spend some time to see whether I can help. So for those you may have already send me some reading my articles and then send me some questions. I always try to answer you maybe 2 days or 3 days. For those you may trigger me writing a new article. Like in the past, someone asked me about API server, so I just test the API server, and then I develop my article and I publish it to share with others. So again, you can reach me, my LinkedIn profile, you can connect me. And in case you have some questions, you can direct to me later. So this is the session I prepared for today. So Mo, I just pass it back to you for the question and answer. Oh, I noticed that there are some question and answer. Let me take a look on what's inside. Okay. Wow. Not bad. Yeah, let me take a look on the question. Okay, I tried to, yeah, I noticed that there are some answer already, or maybe I just try to read it. So the first question is, can we have multiple data structures within the same business network? Yes. Oh, by the way, in fact, the question should be, the question should be better is, can we have multiple data structure within even a chain code? Not just on the same business network, because within a chain code, you can already have multiple application, not just, I mean, not per chain code. Let me try to get back to the to the actual. Let me find out whether I can have. Oh, yeah, I know how to do that. Oh, not this one. Yeah, let me bring out those the train code example here, because that will be better for all of you to understand what. Okay, this is the not this one. Yeah, this one. Okay, the previous one. Okay, you can see this structure. In fact, is just in. We just define one structure, like we call it car in this example. You can imagine if this is a more complicated application, like insurance. I have car data structure. I have insurance policy structure. I have customer structure. So you can define many data structure within a chain code, not just within a business level. Even one chain code, you can have multiple data structure. So yes, you can have multiple structure. So this is one. Another one is, how can we easily add a new organization to the network seamlessly? Does new organization own their node completely, hardware or software? Okay, there are two parts here. The first part is add a new organization. I tell you, it's terribly complicated adding a new organization if you have a network up and running. In fact, you know what? There's a good tutorial in the Hyperledger-Fabric documentation. They tell you how to add one more organization on existing network. Say if you have two orgs, if I need org 3, then you have to do some process. I understand the process, and the process makes sense. But you need to do it step by step to make sure nothing is wrong. So I have to say that adding a new organization is not an easy job, and you have to do a lot of planning. So I would suggest for those who need to edit one, I would suggest you may add it at the very beginning, but not deploy it first. Then when you deploy it, you just use what you have already added, you have already created. You don't need to edit, I mean, one by one every time. So in fact, I received a question yesterday from another company asking for the similar stuff. So again, adding new organization is not an easy task. But the second question is, does new organization own their node completely, hardware or software? The answer is yes or no. If you wish them to make a copy, have a copy of data in their environment, maybe their own data center, if such a case, they need a hardware and a software. But it doesn't mean that they have to get a hardware and software before they can use your network. You can still have a network like this one. Let me get back to bank level here. Okay. You may still have a network like this, but there's a bank gamma. When bank gamma wish to access, since bank gamma does not have the peer node, in that case, they have to use the peer nodes from bank alpha or bank beta. Of course, make sure they agree to do so. But in many cases, the bank gamma, the third organization, they will have their own CA, they would have own peer. So hardware and software, yes, they need that. So this is how we usually, about the adding new organization. And since you bring this up, and for those who are interested to know how to add new organization, there's one article I have published. It's the same as the tutorial that that you found in the Hyperledger-Fabric documentation. If in such a case, I just try to elaborate this, just do it step by step to let you know that, okay, this step, what happens? This step, what happens? So this is how this article looks like. So this is about adding organization. So the next question is, adding something else is adding an orderer in an organization using Kafka and Zookeeper. Okay, good questions. In fact, you know what? If we get back to, again, I always try to refer to some diagram that will be easier for us to discuss. Back to the basic network. Yeah, this is the not the basic network, the first network. In fact, now you see we have only one the OSN, the ordering surface node, or orderer. Sometimes we say this is what we call solo. There are two versions. For redundancy. You have two solutions. One is the Kafka and Zookeeper. The funny thing is, for Kafka and Zookeeper, you have another set of Kafka cluster here. In fact, I have another diagram, but I didn't show you here. In the Kafka diagram, you have 4 Kafka nodes and 3 Zookeeper nodes. And then you can have multiple OSN here for redundancy. So this is what we have up to 1.2 or 1.3. But since then, people have some complaints saying that, okay, this Kafka cluster is very complicated. And in fact, this setup, the organization, the orderer organization has to be a separate one. Can I have an orderer in each organization? So I guess in 1.2 or 1.3, they introduced something called the RAFT, R-A-F-T. So if you are using RAFT, first, you don't need the Kafka cluster. You don't have those 7 nodes here. And you can have multiple orderer nodes. I mean, they are just a cluster by themselves. And if necessary, you can deploy the orderer node on each organization. So this is supported in the RAFT. In fact, I plan to write another article talking about this, but I still haven't got some time. But just let you know that, I mean, based on the documentation, if you are using RAFT, you can do it in you can do it. You can achieve certain redundancy on the orderer organization, but you don't need a Kafka environment. I guess they finally may phase out Kafka because it's really complicated. I still remember once I set up a demo, there are almost 20 containers running on my notebook, so it's quite crazy. Yeah, this is talking. This is the question about the orderer organization with Kafka setup. The next question is it technically possible to exchange any stored value asset within Hyperledger to cryptocurrency? In this case, the Hyperledger value asset will vanish and will be exchanged with cryptocurrency. Technically, yes, but what you need is you have to build. As of today, I don't see some third-party interchain solutions between Hyperledger-Fabric and I just call Ethereum as another example. You can build whatever you like. In fact, you can write your own logic. But the challenge is, will people trust your logic? If your logic have any bugs, no one will use your solution. So in that case, although you can, I can write an application. When I move from my Hyperledger 10 cons, I can add my Ethereum by 10 cons. Technically, definitely you can do it, but you have to do it off chain. Everything when you do it off chain, people will challenge you. Okay, you are centralized. You are someone you can do bad things. What happens if I reduce 10 cons from Hyperledger-Fabric network, but add 20 cons on Ethereum? Who trusts your environment? So this is again, your question is very intelligent. You put technically possible. The answer is always yes. You just use API to talk to both environment. Once you have an identity for Hyperledger-Fabric, you have an identity on Ethereum, which most likely just a wallet and your an Ethereum account. Then you can do whatever you like. But whether it's in production, whether people will trust you, is always not a good solution. So again, technically yes. How can data mining and AI algorithm run on the ledger without affecting scalability? I didn't cover on mining because we don't need mining in Hyperledger-Fabric. You probably know that the consensus is done by the endorsement and the ordering service. So we don't have mining in Hyperledger-Fabric. But in case you are talking about some permissionless blockchain like Ethereum, trust me, scalability is always their headache. They have spent 2 years to how to sort out the scalability solution, and they are coming. They may come up with something soon, but as of today, I still don't think they have already got a good solution. Whether you're using AI algorithm or not, it depends on what type of AI algorithm. I see some projects, but I still not convinced that is something doable. So this is something like data mining and AI algorithm. So I don't have a good answer with that. Can we update the data structure after they have been deployed to add support a new business rule? Oh, okay, good. In fact, when you have something change on your chain code, not just data structure, maybe some business rules, some business logic, you need to add, you will have another chain code. So what you need is to build a new chain code and deploy the new chain code on it. And the Hyperledger-Fabric has a good feature is that you can update your chain code. If you deploy the chain code, you probably notice that you have a version number like version 0, version 1. Say you are using version 1 right now. If you modify your chain code, add some data structure, add some business logic, then you need to deploy it as a version 2 and use update. You do not use instantiate the chain code, but update the chain code. So in that case, the chain code will be updated and the ledger will be kept. So if your data structure is not changing crazily, add a lot of field, you probably can just keep using use the existing ledger. You don't need to do a lot of cut and paste on that. So the answer is yes, you can update your data structure after it's deployed. What you need is just develop a new chain code, add your new data structure, add your new business logic, change your business logic, and once you test everything is good, you just update the chain code to a new version. That is how you can do it. How many chain codes can be on a single peer? I haven't tested yet. I'm doing POC, so I haven't tested the maximum number. Maybe I need to take a look on their source code to see how many chain code can be on a single peer. But I have to let you know that you can deploy several chain codes. I do it every time, for demonstration. And all the channel on peer can access chain code, or we have to configure it. This is interesting question. Okay, when we talk about deploy a chain code, we are saying 2 steps. One is install the chain code on the peer. So this is a static process. Another one is instantiate the chain code on the channel. If you refer to this example, okay, let me use this first network example here. if we install chain code, in fact, I am installing on peer 0, peer 1, peer 0, peer 1. So it's just a static installation. They do some packaging inside the peer, but the chain code is not up and running yet. When you instantiate the chain code, that means the chain code is adding to the channel. So it is my channel. We instantiate the chain code on the channel. So once the chain code, like FabCar, is deploying on my channel, all the peers can access it, and all the data will be updated on each peer. So all the peer on the channel can access the chain code or the ledger that you deploy it. If you need to install one more chain code, you just install it first on the peer and then deploy it on my channel, instantiate it on my channel. Or if a complicated one, you have another channel built, you can deploy on another channel. So again, it's very flexible. I mean, that's the beauty of Hyperledger-Fabric. You can have multiple channels and multiple chain codes, and one chain code can deploy multiple channel, and multiple chain code can deploy on one channel. Whether you do it or not, depending on your real business environment. Again, there's not something that you have to do this or you have not to do this. Everything is depending on your business network and also the business logic or business problem that you wish to solve or the business goal you wish to achieve. So this is these questions. Let me take a look. There's another one. Yeah, let me have some water. How can the network provide analytics to the network participants when maintaining data privacy? Be careful, there are some concepts here. The first one is analytics. Sometimes we call analytics is more on like the performance or like what type of data. I mean the time or maybe the performance. I guess you may not talk about the actual analytics. More on data, I guess. I hope I'm right. How to provide the data to participants, but maintaining some data privacy. For maintaining data privacy, in Hyperledger-Fabric, first, everything written on the ledger will be already visible. It will be already visible to everyone. So if I add a new car, 12, OP1 will see it, OP2 will see it already. If you wish to maintain some data privacy, you can use some feature on Hyperledger-Fabric. In fact, there are two ways. You know what? Less than 24 hours ago, I just published an article talking about data privacy. So that is a very good question. First, you can build a separate channel. As I said, in this case, it's not a good example because I just have 2 org. You can imagine if I have 3 organizations. Oh, why not I just show my latest article such that you can take a look on the 2 solutions I'm talking about. Yep, this is, you can see I just published it, I guess it's yesterday. Data privacy among organizations, channel and private data on Hyperledger-Fabric. So I won't go through everything, but I just show you 2 diagrams, then will be good enough for discussion. Sorry, I keep following it at this stage. Yeah, oh, no, this one. You don't need that. I just okay. Yeah. So this is what I mentioned. If you wish, I mean, some data is not seen by other organizations. Say in this case, the channel 1, 2. In this case, I just create one more channel. So I have one channel called channel all, covering all the 3 organizations. But the channel 1, 2 only cover the OP1 and OP2. So in this case, the ledger for channel 1, 2 only appears on this node, but not this node. So this is how, I mean, data privacy can achieve using the channel. That means you just add one more channel to exclude those organizations you don't wish them to take a look. But there's another approach called private data. Yeah, let me, yeah. So this is another example. So in this case, I use channel all. But then I specify something we call collection to make sure some collection is only accessible by OAuth1 and OAuth2, but not OAuth3. So the interesting part is the private data will be only recorded on this ledger, but not this ledger. The actual implementation, I just let you access my article. You can see how to achieve this. But I mean, just to let you know that for data privacy, you can have these two approach, using channel or using the private data. So finally, if there are 3 organizations and 2 of them, or 1 and or 2 using private channel for conversation, does the data store? Yeah, I just show it in my previous article. You can refer it. You can see some data is not, the data is not found in the OAuth3. But on private data, there's a mechanism using the hashing. This is good because, I mean, is my article still here? Yeah. Let me touch this because it's good questions. Just like this one. In fact, OAuth3 in this case, they have something called hash of private data, like other nodes, but the actual private data is not there. So what can tell is OAuth3 can say that, okay, I know there's public data. There's a private data existing. I only have the hash. But if you wish to take a look on the actual data, I do not have it. OAuth1 and OAuth2 will have that. So this is how, I mean, the answer to your question is the data will not be stored in the OAuth3, but the proof of data is stored in the OAuth3. Again, take a look on the article. It's quite interesting. I like the approach that Hyperledger-Fabric do it that way. So, oh, nice. I keep seeing good questions coming up. So with channels, we can say that Hyperledger-Fabric provides blockchain within a blockchain. I won't say blockchain within a blockchain. If you see it, I would say, okay, it depends on how you define blockchain. I would say Hyperledger-Fabric provide you an environment for business network, and channel is a sub-network within a network. Like the example I showed before. Again, I refer to my previous article. Yeah, like this article, you can see that this is a sub-network. The channel 1, 2 is a sub-network of the bigger network. So in that case, I would use network inside a network rather than blockchain inside a blockchain, because you can see that channel all and channel 1, 2, each channel has their own blockchain. The yellow color, you will have the yellow color, and the red color, you have the red color. So this is, I mean, how we describe channel. I won't use blockchain within a blockchain. I would say it is a network inside a sub-network with a bigger network, and within each sub-network, you will maintain your own blockchain. Or to be more accurate, is you maintain the ledger, and inside the ledger you will have the blockchain. So this is, again, sorry about that. I just keep trying to make it very accurate, but this is how it works. Yeah. Okay. So yes, that's pretty much on the questions. Moon, you just do whatever you like.
Hello, everyone. Can you hear me now? Sorry if there was some issues on my side. It was not loading the videos thank you very much, Casey, for such a nice presentation. It was very, very informative, and I hope all the attendees have learned something new, and it was very interesting. I have few questions. If you can, first let me invite you. Then uh, you can answer these. We have still 5 to 8 minutes. If you don't mind, then we can have a more question that I used to get in different platforms.
Yeah. Okay.
Mm, let me read for you. There is one question that I'm new to Hyperledger Fabric and very interested in it. What is the best way to start my blockchain journey?
I
I
see.
have a lady here, but just a quick, you can give 1 minute on every question. So
Okay.
we
Okay.
cover
Yeah.
5 minutes. We
Yeah.
can
Looks good. Let
find.
me let me jot it down. Yep.
Okay, sure.
Yep. Go ahead. Just tell me others as well. Yep.
Keep in mind that we have 5 minutes more. Uh, so, uh, how someone can start his journey, especially application development, means to playing with the Hyperledger Fabric and get more knowledge about it, because as you know that's very complicated thing to start
Yeah.
with.
Yeah.
uh,
True. I have to say that it's not easy. But the good things is Hyperledger-Fabric in fact come with very good documentation. And the documentation itself, I have to say that sometimes it's too comprehensive, and it's not very, I mean, logically arranged. So that's why, I mean, sometimes you may encounter some challenge. So my suggestion is first you pick up some basic concepts, like the piano, the channel order, how transaction is done. So this part is already in the Hyperledger-Fabric. You just search it. I mean, there's a section called concepts. I mean, understand the concepts. And after that, the most important part is do some hands-on. That is, I keep asking people, even those not technical people, I ask them, if you try to type something, if you do some hands-on, in fact, you will definitely can gain a lot of experience. And not to mention that beside the articles, there are many good articles and also videos available in internet. To be honest, I also learned it from internet quite a lot. So there are many people very interested. They are very enthusiastic. Put up, I mean, those video training and writing some articles to share with others. And that's also why, I mean, what inspires me to share with others. I learn a lot from others, and that's why I just try to publish those articles. And for those, when you try some tutorial on the Hyperledger-Fabric document, the documentation, if you encounter some challenge, like add a new organization, you have to read many times to understand what it means. But you can use my article to make it as a reference. Then you can know, okay, why I do this step, because then do this, I mean, the blog will be updated. Why I need to do this step, then the blog is updated. So then you will understand much clearer, I mean, the underlying technology or the architecture inside the Hyperledger-Fabric. And trust me, you have to spend much time to do it quite repeatedly, and in order to be quite experienced. But that's something worthy to invest, because I will expect more and more people are looking for knowledge or expertise in the Hyperledger-Fabric. And that's how I start, and I hope you guys also follow this.
Okay. Next question is, we see so many cloud providers offering blockchain as a service. Shall I use them? And what do I need to consider before using them? Can you?
Yeah, that's a really good question. If you notice that nowadays most cloud providers AWS, Azure, Oracle, Google. I guess it's not yet, but possibly they will come it up. They are launching their blockchain as a service or a managed blockchain service. I would see the value from them because they will largely reduce some challenge when you launch a new network. Say you can see my first network, right? I mean the basic network, the bank network, right? What happens if I just press a button and everything built for me? So it's ideal, right? I mean, then you can just focus on your chain code, your business logic, everything. My suggestion is first, you probably will use it in production, but I would suggest you still start with learning those fundamental stuff, like what first level looks like, how to add organization, how to remove organization. Because two things. One is you may someday decide to move away from one cloud to another, or to move it back to your data center environment. In that case, you'll have the problem because in the past you just press a button, but now you have to program one by one. And not to mention that you need to do some troubleshooting later. That's one thing. Another thing is, I would suggest be careful. There's a problem called lock-in. If you build everything on one cloud provider, you wish to, for whatever reason, you wish to move to another cloud or move to some your local data center, you will encounter challenge. Not because of, I mean, they are doing very, very good things. It's because they have integrated into their environment. So if that's the case, it's quite difficult for you to move the application back or never back from one cloud provider to another. 2 months ago, I met a customer in Hong Kong. In fact, they have a running application on IBM cloud already, but they decided to move it back. I moved to AWS. Then they find that everything is integrated in the IBM cloud. So what they are going to do? They need to build from the ground. I mean, from the beginning. So just make sure. I mean, when you make a decision, try to